Welcome to Easy Math, making math easy. In this video, we are going to learn how to solve problems based on trigonometric identities. So we've seen all the important identities in the last session. So please do visit that video and then come to this video for better understanding. Uh, if you see, there's a particular pattern in which you have to solve the identities. So, more the number of identities you practice, more the art of solving you'll be able to understand. Yes, so I will give you all the tips that you'll have to follow while solving the identities in this video. Okay, without much further delay, let's quickly move on to our video. Before we move on, we'll look into the important trigonometric identities that we'll be using to solve these problems. And not only that, there are few algebraic identities that we'll be using. That also we'll have a quick look at. Okay. The trigonometric, first, let's look into the trigonometric identities. So there are three important trigonometric identities that you will have to memorize. It's better to memorize so that that comes onto your mind when you solve these problems. Okay. So the first identity is cos square theta plus sine square theta is equal to 1. Okay, so this is the first and foremost identity that you will have to remember. And this will give rise to two more identities. You can transpose and get those two identities. So 1 minus sine square theta is cos square theta and 1 minus cos square theta is sine square theta. Okay. The second identity that you will have to remember is that secant square theta minus tan square theta equal to 1. Okay, so when you transpose, you get 1 plus tan square theta is equal to secant square theta, and then secant square theta minus 1 is equal to tan square theta. Okay. And then the third identity is that cosecant square theta minus cot square theta equal to 1. So this again gives rise to two other identities, that is 1 plus cot square theta is cosecant square theta, and then cosecant square theta minus 1 is equal to cot square theta. Okay, so these are the three trigonometric identities that you will have to remember. And then the algebraic identities that we might use to solve these identity based problems in trigonometry are a square minus b square. So a square minus b square is a minus b into a plus b. Okay. And then number 2, a plus b the whole square. That's a square plus b square plus 2ab. So you should actually remember that a square plus b square is not equal to a plus b the whole square. Okay, the square is for the whole here. Okay, the whole sum here. Here it is individual squares summed up. Okay, so those two are never equal. A plus b the whole square can never be equal to a square plus b square. This has to be remembered when you solve the problems. Okay, now number 3, it's a minus b the whole square. That's nothing but a square plus b square minus 2ab. Okay, again, a square minus b square is not equal to a minus b the whole square. Okay, please remember that. And the fourth one is that a cube plus b cube. This is equal to a plus b into a square plus b square minus ab. A cube plus b cube is equal to a plus b into a square plus b square minus ab. And then the next one is a cube minus b cube. That is nothing but a minus b into a square plus b square plus ab. Okay, so these are a few algebraic identities that you will be applying. Okay, and these are the trigonometric identities that are important that we'll be applying when we solve problems based on trigonometric identities. So first, let's see how to solve our first question. Okay, so the question says that prove that sine a plus cosecant a the whole square plus cos a plus secant a the whole square equal to 7 plus tan square a plus cot square. Okay, such questions you have two ways to prove it. One is you can prove that your left hand side, okay, is equal to the right hand side, meaning you can take the left hand side of the equation, you can rewrite it or you can expand it, simplify it, and then you can prove that that is equal to the right hand side of the equation. Okay, or you can take the right hand side and then you can simplify it and rewrite it such that you get the left hand side of the equation. Okay, so it's up to you. So I suggest that you take the side which has more opportunities to simplify, expand and all that. Okay, where you can use more of identities, where you can convert the reciprocal ratios into the basic ratios of sine and cos, and then do something with it. Okay, so it becomes easy for you to express it as in terms of the other side. Okay, so here I prefer to take the left hand side of the equation. So now let's take the left hand side. Okay, your left hand side is nothing but sine a plus cosecant a the whole square plus cos a plus secant a the whole square. Okay, now what I'm going to do is I can see that there is a mathematical identity, an algebraic identity that can be used. What is that identity? This one is in the form of a plus b the whole square, right? See here, look at this. This is also in the form of a plus b the whole square. We know that a plus b the whole square is a square plus b square plus 2ab. Okay, so now let's apply it here. Here your sine a is your a and your cosecant a is your b. And here cos a is your a and secant a is your b. Okay, so now a plus b the whole square is a square. That's nothing but sine square a. I've told you that sine a the whole square is sine square a, correct? So plus b square, that is cosecant square a, because your b is cosecant a apparently, right? So plus 2 into a into b, 2 into sine a into cosecant a. So we have expanded this part of it. Now we are moving on to this part of the of the LHS. So again, cos a plus secant a the whole square can be written as cos square a plus secant square a plus 2 cos a into secant a by using a plus b the whole square. Okay, now what can be done? Now we look into opportunities to use your trigonometric identities, or you can convert your cosecant and secant into its reciprocal ratios, okay, into the basics of sine ratio as sine and cosine ratio. Okay, so in that form, when you convert, it becomes easy for you to solve it. Okay, so now look at this. I will just write sine square a. I'm going to rewrite the terms. Okay, I'm going to put cos square a next to it. Okay, so sine square a plus cos square a, because everything is getting added. So it is basically your associative property. You can associate any pattern you want. Addition is associative. So I'm going to put cos square a next to this, and then I'm going to write cosecant square a plus secant square a. Okay, plus I have this 2 sine a cosecant a and 2 cos a secant a, right? So what I'm going to do is I'm going to express cosecant A as 1 by sine A plus 2 cos A into secant A as 1 by cos A. Okay, because they are reciprocal ratios getting multiplied, they will get cancelled. Correct. So that is why I'm rewriting this. Okay. So now sine A into 1 by sine A. Now sine A and sine A gets cancelled. Cos A and cos A gets cancelled. So basically I have sine square A plus cos square A is 1. I'm using the trigonometric identity here that says sine square A plus cos square A is 1. And then I'm just going to write cosecant square A as it is and secant square A as it is, plus 2 into 1, that's 2, plus 2 into 1, that's 2. So 2 plus 2 gives you 4. Now I can actually add this 1 and 4, associate them together at the constants, and then write it as 5 plus cosecant square A plus secant square A. Now I'm stuck. I don't know how to move ahead. But my right hand side, I'll have to check the right hand side now. The right hand side is in terms of tan square A and cot square A. And you have something in the terms of secant square A and secant square A. So what can we do? So we have to look into opportunities to convert them in terms of your right hand side. So now can we write cosecant square A in terms of cot square A or tan square A? Or can we write secant square A in terms of tan square A and cot square A? Yes, we can. So we have two more identities that we can use. That is the trigonometric identities, wherein we saw that cosecant square A is 1 plus cot square A. Do you remember that? So instead of cosecant square A, I'm going to write 1 plus cot square A, plus instead of secant square A, I'm going to write 1 plus tan square A. Please write down all the identities and keep it with you so that you will be able to apply it whenever you require. Okay, so please go back, okay, or rewind this video and go back to the place where we have discussed these identities. You can make a note of it. In the previous video, in length, I have discussed all these identities. Please go visit it and write it down. Make a note of it. Okay, so now you know that like terms can be added. Okay, the cos square A and tan square A are basically your trigonometric ratios. Okay, they're variables. Okay, they have a and a, so there's no like term. You can't add them up, but you can add the constants. 5 plus 1 is 7. So you have 7 plus cot square a plus tan square a. That is what you have on the right hand side. See, 7 plus tan square a plus cot square a. And you can rewrite this as 7 plus tan square a plus cot square a. So this is your RHS. So it's very clear that your LHS leads you to your RHS. So finally, you will say hence proved. Okay, so this is how you're going to prove this identity. So now, so how did we do this? We applied the trigonometric identities that we know and the algebraic identities to expand it. Okay, and then we tried to convert the reciprocal ratios into the form of sine and cosine ratio. Correct. So these are your tips. Always remember this when you solve such problems. Let's move on to our next question. So we're supposed to prove that 1 by sine A plus cos A plus 1 by sine A minus cos A equal to 2 sine A by 1 minus 2 cos square A. Okay. So now I prefer to choose my left hand side now as usual because I have opportunities to rewrite the terms here, okay, better than on the right hand side. So I'm going to take the left hand side. Okay. So now what do we have here? We have fractions involving trigonometric ratios. So when we have fractions, what are we supposed to do? Just like how you proceed with your integers or your rational numbers or with your, algebraic fractions, you need to take LCM and proceed. Okay. So what is going to be in it? Be your LCM. It's going to be the product of the terms in the denominator. Okay. So it's sine A plus cos A into sine A minus cos A. Okay. So this is what is going to be your LCM. Okay. So we have put together all the factors. Okay, there's no common factor between these two. So I'm going to take this and take the product as its LCM. Okay, always remember this. Now, how are we going to proceed? So how do I add this up? Now I'm going to observe the denominator of the first fraction. So it has sine A plus cos A. What is the missing factor here? The sine A minus cos A is the missing factor in the first fraction. Okay, you have to compare the LCM and the factor in the fraction and the denominator in the fraction. So which is the missing factor? That sine A minus cos A, that will be multiplied to the numerator. So 1 into sine A minus cos A will give you sine A minus cos A. Okay. Plus, now compare the second fraction, the denominator of the second fraction with the LCM. So what is the missing factor? Sine A plus cos A. That will be multiplied to the numerator. So 1 into sine A plus cos A gives you sine A plus cos A. So now how to simplify this? Now again, we have to keep simplifying. So if you see, minus cos A plus cos A, these are like terms. See, sine A and sine A, cos A and cos A are like terms. So minus cos A and plus cos A gets nullified. It gives you a 0. And sine A plus sine A, like how you deal with algebraic variables, the same way you'll have to deal with this. So sine A plus sine A is going to be 2 sine A. Okay, 2 sine A divided by sine A plus cos A into sine A minus cos A. Now observe, you can use an identity here. It is of the form A plus B into A minus B. So A plus B into A minus B is A square minus B square. So sine A plus cos A into sine A minus cos A is sine square A minus cos square A. All that we are doing is trying to apply the identities, be it algebraic or trigonometric, keep applying it and simplifying so that it leads you to the right hand side. Now see, almost we are there. The numerator is 2 sine A, the numerator 2 sine A, we have got it. Cos square A we have got, but we need 2 cos square A, and there is no sine square A on the right hand side, right? So we need to convert the sine square A into cos square A. How do we do it? We have an identity, right? We have the relationship between cos A and sine A. That's cos square A plus sine square A is equal to 1. I want to write sine square A in terms of cos square A. So what do I do? I write this as sine square A is equal to 1 minus cos square A. So this identity I'm going to substitute here. So what do I get? 2 sine A by, instead of sine square A, I'm going to write 1 minus cos square A because my right hand side apparently does not have sine square A in it. Okay, so and then this cos square A, again I'll have to shift it down. So it will be 1 minus cos square A for the sine square A minus this cos square A. Okay, now sorry, it is 1 minus cos square A for the sine square A and this cos square A. Okay. Now see, again, we have two like terms here. It's minus cos square A minus cos square A. This will be dealt like algebraic variables. So 1 minus x is minus 2x. So minus cos square A minus cos square A is 1 minus 2 cos square A. Correct? So that is what I have on my RHS. This is equal to RHS. So my LHS has led me to my right hand side. So this implies your LHS is equal to your RHS, and hence we have proved this identity. So what do we follow when we solve trigonometric identities? Okay. So whenever we see reciprocal ratios, reciprocal ratios, or quotient ratios like tan theta and cot theta, or cosecant theta and sine secant theta, the reciprocal ratios, what do we do? We prefer to convert them into sine and cos. Okay, convert them into sine and cos. Okay, if you have reciprocal ratios, convert them into your basic ratios, that is your sine and cosine ratio. Okay, so moving ahead with it becomes easier. Okay, and always keep looking into the right hand side in whatever terms it is. I try to as much as possible take your left hand side into those terms. Okay, now number two, whenever you have fractions, okay, whenever you have fractions, what do you need to do? You need to add them up or subtract them up. Okay, or you have to simplify them rather, depending on what operations are there, by taking LCM. Okay, at times, we also try to multiply the numerator and denominator by the conjugate of either the numerator or the denominator. That we'll be looking into in our next video. Okay, that comes in the next type. And then thirdly, what did we see? Whenever we had algebraic identities, okay, or trigonometric identities, we try to apply them, right? So these are the basic things that you will follow. And trust me, proving trigonometric identities is not at all difficult. Okay, so if you practice well, nothing like that, you will be able to crack any type of problem. So with that, we come to an end of this video. So we'll see more identities in the next class. So please do make a note of all the trigonometric identities, the very important identities, basic identities, formulas that we had seen, and then even the algebraic identities. Please make a note of it so that you will be able to recognize them whenever you see them in the problems, and you will be able to apply them at with ease. Okay, so practice, practice. Okay, practice is the mantra that makes mathematics really easy. Okay, as I always tell you, practice makes a man perfect. Okay, so please do note down and start solving problems with a notebook and a pen. Please, I recommend you not to study or go through the concepts. Orally when it comes to mathematics, it is always better that you sit and you practice. Okay, so we'll be coming up with a lot of tips and tricks before you take up your ICSE or CBSE or your state board exams. So not only for mathematics, we are planning to come up with tips for even other subjects. Just keep waiting. And thank you for all your support. If you like my videos, please click on the like button, subscribe, and share it so that it reaches all deserving students. Thank you.